Hello everyone and welcome to another week of Python. Since you all know that we are learning how to grasp a good understanding of the world of Python so that when you will dive, in the world of LLM Gen AI, you become comfortable from the coding point of. And today in our week 4 of Python development, we're going to be covering some amazing topics that will become kind of a day-to-day activity for all data scientists working with packages like NumPy, Pandas, and doing all these data activities of slicing data, filtering data, merging data, cleaning data is going to be your day-to-day task. So in today's session, we're going to be learning about the wonderful power of NumPy and Pandas. So for that, you will get all these resources. So don't worry about that. Just enjoy the course. So what I'm doing is, as you know that we, in the world of Python, especially working in the notebooks, we import certain packages that makes our life easy. And in that journey, we are learning about NumPy and Pandas today. NumPy is a package that allows us to do a lot of mathematical and statistical work. And on the other hand, Pandas allows us to do more of a structural data frame related works, where you upload data frames like CSV, Excel, tab delimited, comma separated files, and play with those data, either cleaning those data, observing those data, visualizing those data, so that once your data is ready, you can feed that to any machine learning model or maybe, process for further data pipeline. So we'll start with NumPy and then gradually we'll go towards the Pandas world of it. So most of the time when you download Anaconda or you're working on Google Colab or you're working on IDs like Visual Studio and you install Python, numbers and Pandas get automatically installed in the case of Anaconda and Google Colab. But if you have downloaded Python separately, then in those cases you need to import these packages. So all you have to do is do pip install NumPy and the package will be installed. Once it is installed, we import the package, import NumPy as NP. So this NP that you see is an alias. In Python, we have some standards. I mean, here I can give literally anything. I can type Jayant also. But there are some, industry practice. We are following those. So NP is the industrial way, right? Good coding practice to give an alias to NumPy. So how does it work? As you can see on my screen, I'm defining an array, NumPy, that is np.array, and it declares a one-dimensional array for me and saves it in a variable called arr. Then, if I pass two square bracket elements, you see first list and second list separated by a comma, then it becomes a matrix. How does it look? Let me run this cell in a different cell, right? So if I run this thing, so you see this is my one-dimensional array. And if I print my two-dimensional array, so you see, so you got a, two rows and three columns data, a matrix. This allows us to play with different dimension of data. We can do a lot of wonderful things, like I can, let's say if I have ARR, I want to know what is there at the 0th location, right? At 0th location or the index value of 0, I have 1. See this? 1 got printed. If you want a range of data, like from certain elements to another element. So starting from position 1, this is in Python, the counting starts from 0. So 0, 1, this is a position. This is 2, this is 3, and this is 4. So what I'm doing is from 1 position till n minus 1. So 1, 2, 3. 3 elements got printed. Similarly, I can fetch data for a matrix also instead of a single array. But in matrix, you will get the entire row because it's a two-dimensional array. And in metrics also, you can fetch the range of values too, right? So at this location, at this point, this number got saved. Got it? We can do some conditional checks also. What does conditional checks mean? For example, if you look at here, I want to check even numbers, whether they are even or not. So in the entire array, I have 1, 2, 3, 4, 5. So what I'm doing here is element divide by 2, the remainder should be equal to 0. If I divide 1 by 2, remainder will not be 0. Hence, that did not get printed. But 2 divided by 2, remainder 0. Hence, 2 got printed. So these are some kind of an operations you can do with the package as NumPy. Then there are certain advanced things that you can do, which is called your vectorization, converting your data into vectors, and broadcasting. Basically, broadcasting means when you want to make a change to an entire, NumPy array or a matrix. So let's define these two metrics, x and y. What if I have to add them? Right. So what will happen? 1 will add it to 10, 2 will get added to 20, and 3 will get added to 30. So you see, x plus y will give me the sum. Simply multiplication also, 10 into 1, 20 into 2, and 30 into 3. You can broadcast also. What if I want to square each and every number? 1 square, 2 square, and 3 square. We can arrange and reshape also. What does arrange and reshape means? What happens is, so you see, I have an array, I declare an array of size 6, right? And then I'm saying that convert that into a matrix of 2 rows and 3 columns. So you see this thing, mat becomes an array, np.arrange 6 values. If this is confusing, you can see this like this. I'll add a cell here and run it. So np.arrange, what it has done arrange, it has started counting from 0 and given me values till 5. So I declared an np array first and then reshaping it to 2, 3. Okay, so this way I got this matrix. And similarly, another vector. Then I can add these values. So what has happened? 10, 0 gives me 10. 10 plus 3 gives me 13. 20 plus 1, 21. 20 plus 4 gives me 24. Right? Or I can do sum also. Mat.sum, what it will do? It will give me the sum of all the numbers. 5 plus 4, 9, 9 plus 3, 12, 12 plus 3, 15. So you see 15 here. And at the same time, you can even calculate the mean and median and some mathematical statistical information also that could be really helpful. Right? And similarly, just like in NumPy help us with mathematical related operations, Pandas help us with data at a tabular form. You see, it's called Panda series. So import Pandas as PD. Then I'm defining a series. These are the values. But in Pandas, I have to give the index also. Right? So if I run this cell, you see a Panda series got defined with these values and these index. If I do type, say it's a Panda series. And what is happening in this cell? I'm defining a series and then printing it. So you see this, the series got printed. Then just like your NumPy, we can access element here also. We can call element by their index. So if I do b, s.b, 20 will get printed. Or you can print multiple values also. But this is not an ideal use case. Here I would have preferred NumPy. Then why do we need Pandas? When you have complex architecture like this, you have a dictionary, keys, and values. Key, value, key, value. So when I pass a dictionary to a data frame, so this is how it gets converted. You see that? This becomes my first column. This becomes my second column, and this becomes my third column. And these three things becomes my column names. So column name, all the value. Column name age, all the values, and column name score, all the values. You can fetch one entire column by writing df.age. If I write it here, see, entire column got fetched. You can fetch one element also, or one entire row. So when I did this, ilog, what it does, it gives me the location. Ilog 0 means in this data frame at 0th index, this value is there, correct? At 0th index. So ilog gives me the index value. And then you can apply a filter too. Filter means I want only information where age is greater than 30. So when I run this cell, see, only those rows got printed where the age is above 30. But this is good when you only have one tabular data. What if you have multiple data frames, multiple data sources? Then there is a chance you have to join them, merge them, and that is what we'll do now. So let's create another data frame sales. So now I already have one data frame here, data frame df, and I created another data frame called sales. Now I'll merge them. That means data frame join, outer join, just like SQL. Okay. One condition is name. Wherever the name will match, this will be joined. So if you see the data frame merged, this is how it looks. This merged data frame. Now you want to add one more column is senior. That means whenever someone is above 30 years, I want to give them a tag of senior. So what I did, data frame, column name, and added the condition. Then what I want to do is grouping by on the basis of whether you are a senior employee or not. Data frame, group by, column senior. I want to see the average salary. Okay. So people who are, less than 30 years of old, their average salary is 87.5. And people who are above 30 years old, their average is also 87.5. Because this is a mock-up data, right? But you got the idea? Grouping by on a condition. Right? So not only you can calculate mean, you can calculate other things also. So you see, people who are not senior, their maximum salary is 90. And people who are senior, their maximum salary is 95. However, you might have noticed something. What is this? This is called null values. When computer or compiler does not find the value, it assigns a null value directly. In Python, we can handle them. For example, I'm declaring a new data frame called df2 with intentionally adding some null values. How do we check null values? Data frame is NA, means data frame and a function that checks or a method that checks whether a particular value is none or not. If it is none, it increases the counter. Like the counter becomes 1. And I'm doing a sum of all those ones. Right? So see this thing. There is one column, one value within under the column name with none. There is one row with age as none, and there is one element in score with none. Got it? Then there are multiple ways to fix this thing. What if I want to fill the missing values with main value? What will I do? I will say that in the original data frame, in the age column, wherever you see null value, replace that with the mean value. So if I show you, the mean value is 28, right? So this is where the null value is there. This is what we want to, trying to replace that with the null value, with the mean value basically, right? Or what if you want to drop them? You're like, I'm not interested. Just simply drop the null values. See, it has dropped the null values and giving you the output, right? And what if there are duplicates? You can drop them also by df.duplicates, and it will drop the duplicates values, right? So you see, null values can got replaced with 28, or I can delete the values wherever none is there, got deleted. This got deleted, this got deleted, right? And this got deleted. Or if there are duplicates, I can drop also. If there are duplicate patients, students, employees, I can delete them also. Right. So these are some amazing tasks that you can do when you are working with NumPys and Pandas. So if you found this interesting and amazing, trust me, this basic fundamentals that we have done today will be really helpful for you going forward. So stay tuned. We are going to cover amazing chapter next week that will cover your visualization. Until then, I'm Jayant Maharaj. Thank you very much.